Hello everyone, welcome to our YouTube channel Calculus Hub UPI Cairo. This video number 3 in Calculus 2 course. Title of the video is the trigonometric integrals. This video is consisting of two parts. This is the first part, integration of trigonometric functions with even and odd powers. I'm Hisham Hosni Hussein, Associate Professor of Applied Mathematics. Prepare your pen, your notes, and let's go. In this video, we are going to discuss two types of integrals. The first type is the integration of sine to the power nx times cosine to the power mx dx. The second type of integrals is the integration of sec to the power mx times tan to the power nx dx. For this first type of integrals, here we have three cases to discuss. The first case, if n is the power of sine, if this n is positive odd number. The second case, if m is the power of cosine, if m is positive odd number. The third case, if both m and n are evens, are positive even numbers. Okay, starting by if n is positive odd, then we make a substitution that z equals to cosine x. So dz in this case will be negative sine x dx. And we use the trigonometric identity that in the sine to the power 2x equals to 1 minus cosine to the power 2x. If m, which is the exponent of cosine, is positive odd, then we make the substitution that z equals to sine x. So the z in this case would be cosine x dx, and cosine square x would be 1 minus sine square x. If both m and n are even, so we use the identities of the double angle rule. Sine power 2 equals to half 1 minus cosine 2x. Cosine square x equals to half 1 plus cosine 2x. And sine x cosine x equals to half sine 2x.
Okay, so in this set of problems, it's requested to evaluate the following integrals. This set of integrals are integrations of trig functions with even and odd powers. Okay, starting with this problem 1. Here we have a product of two functions, sine to the power 7 multiplied by cosine to the power 3. So here we have product of functions sine and cosine, both with odd power. So as we mentioned in the lecture, we will split one of the functions with the lower power. Here it's cosine to the power 3. So evaluate the integration of sine to the power 7 x multiplied by cosine to the power 3, which is cosine to the power 2x times cosine x dx. Already we know that in this cosine is the derivative of sine, so this means that this is the sine for transforming whole of the integrand to be as a function of sine. Here we have cosine squared, which is 1 minus sine squared. It's 1 minus sine power 2x. Okay, now write the integration of sine to the power 7 x multiplied by 1 minus sine to the power 2x, which is multiplied by cosine x dx. If we let t equals to sine x, so t dash will be cosine x. Then replace the integration of t to the power 7 times 1 minus t to the power 2 times t dash dx. This equal to integration of t to the power 7 times 1 minus t to the power 7 times t squared. This will be t to the power 7 minus t to the power 9 times t dash dx. Now we can integrate this function. Integration of t to the power 7, this will be t to the power 8 divided by 8 minus t to the power 10 divided by 10 plus c. Okay, what is t? T is sine x, so this would be 1 divided by 8 sine to the power 8 x minus 1 divided by 10 sine to the power 10 x plus c. This is the first one. The second one, the sine power 3 cosine to the power 4. So we will split one of the sine. This will be integration of sine to the power 2x times cosine to the power 4x multiplied by sine x dx. Already we know that in the sine is the derivative of cosine. but we still need negative, so just multiply by negative in and out. Okay, sine is negative sine is the derivative of cosine, so we need to transform whole of this integrand to be as a function of cosine. Here it's cosine to the power 4. What about sine squared? We replace it to be 1 minus cosine power 2x. So the integration will be cosine power 4 times 1. It's a cosine to the power 4x minus cosine power 4 times cosine squared. This cosine to the power 6x times negative sine x dx by letting t equals to cosine x. So t dash will be negative sine x. Then this would be the integration of t to the power 4 minus t to the power 6 times t dash dx. So the integration now, integrating the function, this will be t to the power 5 divided by 5 minus t to the power 7 divided by 7 plus c. What is t? This cosine. So it's 1 over 5 cosine to the power 5x minus 1 divided by 7 cosine to the power 7x plus c. Going to the next problem. Here we have sine square cosine power 4. Sine square cosine power 4, both functions with even power. My idea is to transform both into one of the functions. It's better to transform it to be cosine to the power 4 and then use the reduction formula. It will be possible to replace this sine squared to be 1 minus cosine to the power 2t. So the integration will be integration of 1 minus cosine squared t multiplied by cosine to the power 4t dt, which is integration cosine to the power 4t minus cosine to the power 4 times the cosine to the power 2, this cosine to the power 6t dt. Okay, so now we can use the reduction formula. We have here in in equals to integration of cosine to the power nx dx. Using the integration by parts, first we have to indicate that we will split this function into product of two functions, cosine to the power n minus 1 x times cosine x dx. Okay, and then apply the integration by parts. U will be cosine to the power n minus 1 x u dash will be derivative of cosine to the power n minus 1 is n minus 1 times the cosine to the power n minus 2x times the derivative. What's inside the derivative of cosine is negative sine x. V dash equals to cosine x. So V is integration of cosine, this sine x. Then the integration in will be u times v, this u times v, which is cosine to the power n minus 1 x times sine x. This is u times v minus the integration of u dash times v, of u dash times v. Okay, minus negative, negative, it's positive. Here we have n minus 1 integration of cosine to the power n minus 2x, n minus 2x times sine, this sine to the power 2x dx. Replacing the sine square to be 1 minus sine square, so we'll get sine square will be 1 minus cosine power 2x. So in is cosine to the power n minus 1x times sine x plus n minus 1 multiplied by cosine to the power n minus 2 times 1, this cosine to the power n minus 2, which is in minus 2. The integration of in minus 2 minus cosine to the power n minus 2 times the cosine squared, this cosine to the power n, which is the integration of in. Now we need to solve for this in, so we need to switch this in to the left hand side. We get that in plus n minus 1 in. This equals to cosine to the power n minus 1x times sine x plus n minus 1 in minus 2. Okay, the target is we need to solve for in. As we need to solve for in, so we can factor this in. So after factoring in, we get in multiplied by 1 plus n minus 1. 1 plus n minus 1, this is simply n. To solve for in, we will get the following. Okay, in will be, so in after dividing by n will be, it's 1 over n cosine to the power n minus 1x times sine x plus n minus 1 divided by n I n minus 2. Okay, we need to evaluate cosine to the power 6, which is I6, and cosine to the power 4, which is I4. So this I6 and this I4. So go for the reduction formula again to evaluate this I4 and I6. So I6 equals to 1 over 6 cosine to the power 5 x times sine x plus n minus 1, which is 6 minus 1, 5 divided by 6, I4. Okay, but we still have I4. So I4 will be this 1 divided by 4, replacing n by 4. 1 divided by 4 cosine to the power 4 minus 1, this is 3 cosine to the power 3x times sine x plus replace n by 4, this 3 divided by 4 I2. We still have I2. So I2 will be, substituting the same reduction formula, this will be 1 over 2 cosine to the power 2 minus 1, which is cosine x times sine x. Replace n by 2. This will be 2 minus 1. This 1 divided by 2 is plus 1 divided by 2 I naught. Okay, what is I naught? This is simply x. So now we have I4 and I6. Substitute with this I2 to get I4, complete form in I4, and substitute with I4 in I6 to get a complete form in for I6, and then substitute with this I4 and I6 in the integral. Here this is the place for I4, here this is the place for I6. Okay, another problem. This cosine to the power 5 alpha divided by root sine alpha. This cosine to the power 5. Cosine to the power 5 alpha divided by root of sine alpha d alpha. Already here we have odd power for cosine, which means that we will split 1 from this cosine to get cosine to the power 4 alpha divided by root sine alpha multiplied by cosine alpha d alpha. Okay, so this cosine is the derivative of sine. Here it's already sine, so we need to transform this cosine to the power 4 alpha to be sine. How come? Already we know that since cosine to the power 4 alpha equals to cosine to the power 2 alpha all to the power 2. Okay, cosine to the power 2 alpha can be written as 1 minus sine squared alpha to the power 2, which is first square, first times second times 2, 2 sine squared alpha plus the second square, which is sine to the power 4 alpha. Okay, so replace this cosine to the power 4 by this form. Then the integration will be integration of 1 minus 2 sine squared alpha, 1 minus 2 sine squared alpha plus sine to the power 4 alpha, which is multiplied by 1 divided by root sine alpha times cosine alpha d alpha. Okay, now we have t and t dash. T equals 2 sine alpha. T dash equals 2 cosine alpha. So the integration will be integration of 1 minus 2t squared plus t to the power 4, this multiplied by t to the power negative half times t dash d alpha. Distributing this t to the power negative half on the three terms in this bracket, we will get integration t to the power negative half times 1, this t to the power negative half, minus t2 multiplied by t squared times t to the power negative half, this t to the power 3 over 2, plus t to the power 4 times t to the power negative half, this t to the power 7 over 2, times t dash d alpha. So the integration now will be raise the power by 1 and divide by the new power, t to the power half divided by half, minus 2 t to the power 5 over 2 divided by 5 over 2, plus t to the power 9 over 2 divided by 9 over 2 plus c, where t, you have to do the back substitution step, where t is sine alpha.
Regarding the other type of integrals, integration of sec to the power nx multiplied by tan to the power mx dx, we have three cases too. The first case, if n is even, So if n is even, we let in here is the power of sec. So we let in z here equals to 10x. So dz in this case is sec power 2x dx. And we use the identity that in sec power 2x equals to 1 plus 10 square x. If m is odd, m here is the power of 10. So in this case, z will be sec x. So dz is sec x 10x dx. And we replace each 10 square x by sec power 2x minus 1. If n is odd and m is even at the same time, so in this case, we use the reduction formula for in equals to integration of sec to the power n x dx.
Okay, another problem to solve. This for sec 10. Here we have t 10 to the power 3 times sec to the power 1. So if you go to the summary, you will find the case if the power of 10 is odd. If the power of 10 is odd, so we will split one from sec and one from 10 to get integration of 10 square x multiplied by sec x 10x dx. Sec 10 is the derivative of sec. So this means that we need to transform this 10 square to be as a function of sec. So if we let t equals to sec x, then t dash will be sec x 10x, where this 10 square will be replaced by sec square x minus 1. Okay, so the integral now will be I equals to the integration now. No need to rename it as I. So the integral now will be integration of t, which is sec. This will be t square minus 1 multiplied by t dash dx. Integrate, raise the power by 1, divided by the new power. This will be t power 3 divided by 3 minus t plus c. What is t? This is sec. So the integration now will be 1 over 3 sec to the power 3x minus sec x plus c. Okay, going to another problem to solve. Here we have the integration of 10 to the power 4 times sec to the power 6. Both the powers for sec and 10 both are even, but we are focusing on the even power for sec. Here the power of sec is even, so this means that we will split sec power 2 from this sec power 6 to write it as 10 to the power 4x multiplied by sec to the power 4x times sec to the power 2x dx. Sec to the power 2 is the derivative of 10. Okay, so if we let in t equals to 10x, then t dash will be sec square x. Okay, so this means that we need to represent each function, the remaining form of the integrand, the remaining function of the integrand, after splitting the sec square, we need to represent the remaining functions, the remaining product of the integrand to be function of 10. Okay, already here we have 10 to the power 4. What about this sec to the power 4? Sec to the power 4x can be rewritten as sec square x power 2. Okay, sec power 2 is 1 plus 10 square, 1 plus 10 square x power 2. This will be the first square, first times second times 2, plus the second square, which is 10 to the power 4. Substituting with the sec power 4, we will get integration of 10 to the power 4x times sec to the power 4, which will be 1 plus 2 tan square x plus tan power 4x times sec square x dx. Here tan is t, sec square is t dash. So replace replace tan by t. This will be t power 4 times 1 plus 2t square plus t power 4 times t dash dx. This equals to, distribute this t to the power 4 on each term in this bracket, t power 4 times 1, t power 4 times t square, and t power 4, times t power 4. This will be t power 4 times 1, this t power 4, plus 2. T power 4 times t square, this t power 6, plus t power 4 times t power 4, this t power 8 times t dash dx. Now integrate. The integration will be, what's the integration of t to the power 4? This t to the power 5 divided by 5, plus 2. What's the integration of t power 6? This t power 7 divided by 7, plus what's the integration of t to the power 8? This t to the power 9 divided by 9, plus c. And you have at the end to replace each t by tan